This tutorial is for 4th grade, Module 6, Lesson 8. In this lesson, we're going to look at how we can compose and decompose whole numbers, tenths, and hundredths. For question 1, I have an area model that has been shaded to represent the fraction 250 hundredths. 250 hundredths is an improper fraction because the numerator is greater than the denominator, and that means I have more than one whole. If you look at my shaded area model, you can see that each of the first two models have been completely shaded in. There are 100 pieces and all of them have been shaded in, and 100 100ths is the same thing as one whole. The second model shows the same thing. 100 pieces shaded in out of the 100 available, and that also equals one whole. In the last model, I have 50 pieces shaded in out of the 100, so that would represent 50 hundredths. The first part of the question says 250 hundredths is the same as how many tenths? Well, a tenth would be one column in the area model. Each whole number is made up of 10 tenths. So that first model shows 10 tenths. The second model also shows 10 tenths. And the last one shows 5 tenths because 5 of the columns are shaded in. Altogether, that gives me 25 tenths. 10 for each of the whole numbers, and then 5 more for the last model. This also means that I have two ones because I have two whole models shaded in. Each one of those represents one whole. And 5 tenths because, again, each of these columns in the last model is 1/10. To write this in standard form, we would say we have 2 wholes and 5 tenths. In the next section, we're going to decompose whole numbers into tenths and then tenths into hundredths. I start with 2 ones, and you can see I have 2 in my ones place, and I'm going to show the 2 ones as tenths. Well, it takes 10 tenths to make one whole, so I'll start by shading in 10 of the 10th discs. So now I have one whole shaded in. I need to shade in another 10 discs to represent the second whole. Altogether, to show 2 ones, I've shaded in 20 of the 10th discs. So 2 ones is the same thing as 20 tenths. Now going across, instead of having 2 ones, I have 2 tenths. And now I'm going to decompose those into hundredths. It takes 10 hundredths to make 1/10. So again, I'll start by shading in 10 of the discs to show 1/10. This shows us that 10 hundredths represents 1/10. Now I will shade in another 10 discs to represent the other 10th. In all, I have 20 of the discs shaded in. That tells us that 2/10 is the same thing as 20 hundredths. In the last two sections, we'll decompose our numbers into tenths and hundredths. The first number I have is 1 whole. 1 whole is the same thing as 10 tenths. It takes 10 tenths to make a whole. Going across, I have 2 wholes. That means it takes 20 tenths to make 2 wholes. If I go to problem C, I have 1 whole and 7 tenths. Well, it takes 10 tenths to make 1 whole, and then 7 tenths to make 7 tenths, so altogether that's 17 tenths. Down below I have 10 wholes. Well, if it takes 10 tenths to make 1 whole, it would take 100 tenths to make 10 holes. And then I also have 7 more tenths. So 10 and 7 tenths is the same thing as 107 tenths. Down below, I'm going to break the numbers into hundredths. It takes 100 hundredths to make 1 whole. Therefore, it would take 100 hundredths to make 1 whole for part C, and then 70 hundredths to make 7 tenths. That means I need 170 hundredths to make 1 7 tenths. Since it takes 100 hundredths to make 1 whole, it would take 1,000 hundredths to make 10 wholes. And then I still need 70 hundredths to make the 7 tenths. So it would take 1,070 hundredths to make 10 wholes and 7 tenths.